This is about Year 12 methods. It's about sample statistics and working out probabilities. A fish tank contains 8 gold and 8 red fish. Since our sample size of n is only 16, it's not very big. So I've got to be careful. I've got to use binomial and I've got to use without replacement, so I'll need a tree diagram. What are the possible values of the proportion p hat? Okay, so if x is the number of red fish, then I can get no red fish, 1 red fish, 2 red fish, or 3 red fish. And if p hat is the proportion of red fish, then that is 0, that is 1/3, that is 2/3, and that is 1, and that's correct. To find out the probability that p hat equals p hat, I need a tree diagram based on my 8 fish. So if I draw my first fish, I can get gold or red, and that is 8 out of 16, 8 out of 16. For my second, I can get gold or red, and that's 7 out of 15, 8 out of 15. And I can get gold or red, and that is 8 out of 15, 7 out of 15. And for the third, I can get gold or red, gold or red, gold or red, gold or red. And this would be 6 out of 14, and this would be 6 out of 14. The probability of getting red, red, and red is identically the same as getting gold, gold, and gold. 8 out of 16 times 7 out of 15 times 6 out of 14, 8 out of 16, 17, 7 out of 15, 6 out of 14. 6 goes into 16, so 2 goes into that 3 times, 2 goes into that 8 times, 8 goes into that once, 8 goes into that once, 7 goes into that once and goes into 14 twice, 3 goes into 15 5 times, 1 on 10. So of getting no reds, it's 1/10. Getting 3 reds is 1/10. Because I've got an equal number of goldfish, gold and red, this tree diagram is perfectly equal on either side. Since it's going to be perfectly symmetrical, the probability of getting 1 or 2 is identically the same, so they're both going to be 4 out of 10. Okay, so I've completed my probabilities. I've used the tree diagram to come up with them. If you didn't realise about this 4/10, I could. Getting 1 red is gold, gold, red, and that's 8 out of 14. So it's 8 out of 16 times 7 out of 15 times 8 out of 14. And it's gold, red, gold, which is 7 out of 14, 8 out of 16, 8 out of 15, 7 out of 14, 8 by 7 by 8, and 16, 15, 14. And it's getting 1 red. Red, gold, gold, which will be 8, 8, 7 on top. So it's actually that by 3, because it can occur 3 different ways. 8 goes into 16 twice, 7 goes into 14 twice, 2 goes into 8 4 times, which leaves me with 2 goes into that twice. I've lost my train of thought here. Where'd my 50? Oh, 5, 3 goes into that 5 times. So I've got some reason that didn't work. I'll do that again. 3 goes into 15 5 times. 8 goes into 16 twice. 7 goes into 14 twice. 2 goes into 8 4 times. I'm left on the top with a 4. I'm left on the top with 5 times 2, 4/10, and there's my answer, 4/10. Okay, part B. Find the probability the proportion of redfish in the sample is more than 0.25. Okay, that's less than 0.25. That's more than 0.25 because that's 0.333. That's more than 0.25. That's 0.666. And that's more than 0.25. So my probability is going to be 4/10 plus 4/10 plus 1/10, 9/10. 9 on 10 is my answer. And I've got a little conditional probability happening here. P hat equals 1/3 intersect B hat is bigger than 1/4 over the probability that P hat is bigger than 1/4. So my bottom, that's bigger than 1/4, that's bigger than 1/4, that's bigger than 1/4. Oh, of course, that's the same as what's on the bottom there, so that's 0.9, 9/10. The intersection of the top equal to 1/3 or bigger than 1/4 is actually equal to 1/3, and equal to 1/3 is 0.4. So 4/9 is my answer.